Hi everyone. It's me again. I promise it won't be the same presentation as yesterday. So today I will present you how we use citizen science in X-ray astronomy. So with the tool we developed for XMM Newton, and so let's start. So I'll be first presenting why we need citizen science in our X-ray community. So if you remember yesterday, I said that Claxboy is a fantastic tool for automatic classification, but and it has a lot of advantages, but there is still small training sample, and this is one drawback which is everywhere in different fields of astrophysics. So one way to enlarge the training samples is to better exploit the archives and to use citizen science for that. So you may know this experiment called Galaxy Zoo, which was developed in 2007, well, released in 2007, and which has a tremendous success. It was designed at so recognizing galaxy morphologies using SDSS images. And very quickly, it had like 1 million galaxies classified by thousands of users. And so it was really important to develop new training sample of galaxy morphologies. So we have actually, so they have actually a Galaxy Zoo release that is currently still used in machine learning experiments. And they were also, so this experiment was also allowed the discovery of these nice objects, the green peas, because they are small and green. So they are actually dwarf galaxies, dwarf compact galaxies, on which a lot of science was made and remains to be done. So now that we know that citizen science is a nice tool, how to implement it in X-ray? So we've been developing this citizen science online platform called Klaxon for classification of X-ray sources for novices. So it's about source classification of XMM Newton sources. And you can see here a glimpse at the classification page. So you have different software, and you have the XMM Newton. You have the UV and optical and infrared data. So the optical and infrared HIPs change given the location of your source to always show the deepest and the most resolved survey. And you have also access to, so users are asked at this point to classify the source in one of these four classes, so AGN, star, X-ray binary, or something else. So far it was only for point-like sources. And you have also here the X-ray spectrum and the X-ray light curve. So obviously these are pretty high-level science products that cannot be interpreted by the general public, but so this is why there is all a process of training for the users. So so volunteers first are given tutorials to recognize sources in an interactive way, and then they are trained on known sources. So it's basically trial and error. So if at each step they are shown the answer of the previous classification and the possible reason why it could be classified as this class. So this is the training step, but after they classified more than 20 objects and with at least 75% of success, they access level 2, so they can classify unknown sources. And so these are recorded in the database and can be used later so by the scientists. And the idea is that we can have reliable classifications thanks to the wisdom of crowds. So if a single source was classified as AGN by 19 users and star by 1 user, then it's probably an AGN. And so I will show you, I will give more quantities later. And so you can see here, so the success rate estimated on the training sample of known sources for the 5 most active users. So you see that they did thousands of classifications each, which is impressive. And they all have more than, well, or almost 90% of success rates, which is amazing too. So the next question is, well, it's also a way to get people interested in X-ray astronomy, of course, and you want to keep them interested over time. So for that, you have to gamify the experiments. So this is done by the general leaderboard, but also weekly ranking, and users can access their own classification map. So to see the object that they classified, and also there is this system of daily streak. So with a kind of reward when they keep using the website daily. Okay, so let me now show some results. So far, so more than 200 people accessed the level 2, and more than 200 unknown sources were classified more than 20 times. So this is still a small sample, but I'm doing with what I have now. And you see here the distribution of the number of classification for known sources and unknown sources. So known sources, it's obviously the training sample, and obviously people in the training phase always go through them, so they are classified a lot of times. But it's in log scale, so you see that actually a lot of unknown sources were classified, let's say, more than 10 times, which is not yet enough to exploit them scientifically. But you see here the confusion matrix of user classification for known sources, so they have good precision and recall. This is using the, so as I said, the majority classification given all user answer on each source. And here is the confusion matrix on unknown sources. So how do I get the true types here? It's using Klaxboy. And actually, you see that they do not always agree, especially on X-ray binaries. And actually, so this is where I was asking to myself, I was wondering, who is right, the Klaxboy or Klaxon? And I visually inspected so these sources, and it turned out, so you don't have to trust me, but in most cases, the Klaxon-based classification seems to be more trustable. And Klaxon, so it's not only for the general public, I would say. It's also a nice way to train the human in the loop in the task of developing a source classifier. Okay, so I call this slide anomaly detection. Let's say just, okay, serendipitous discovery. And so we provide also a bunch of tools for the users to give more input on their on the source they classify. So for example, they can leave comments. And you can see that some people did use that. And so you see here two sources on which they commented that they could be interesting. So this one is the known supernova remnant, which is obviously not a type provided in the classification page. And this one, so it's actually known quasar, but it has this soft X-ray extent, well, or maybe noise, I don't know, but it was kind of confusing maybe the user. I don't know if that's real. Probably it's not significant. And so, but so as a next step, we also tried to develop more advanced classification for more difficult source populations. And so this was only for experienced users. And so we have this sample of ULX candidates, and which are extremely difficult to classify sometimes. So you see here two new types, being ULX and volume of hot gas. So same principle, they are trained on a sample of sources, and then they can give classification on unknown sources. But I'm running out of time, so let me show you the impact as an outreach tool. So Klaxon now exists in 5 languages, Spanish, Greek, French, English, and Italian. And we made a user survey in 2022. And the results show that Klaxon reached actually quite diverse audience with a lot of different ages, from 11 to 60, and a lot of different profiles. So some X-ray astronomers use it. I use it myself, and but many people just curious of science like to use it too. Okay, so let me just say that we prepare a bunch of new improvements, and this survey was also the opportunity to ask the user what features they want to have in the experiment. And I would say this is very important as a citizen science experiment to stay close to the people. Okay. So we have here 5 improvements. So discovery gallery is the one that they want to have like a glimpse at the discoveries that were actually made by that they did make as a volunteer community. And so as I said, we also developed the challenge of the month. So the challenges, not of the month yet, and the weekly ranking. And so this is my conclusion. So Klaxon is a citizen science platform which is designed so to enlarge the training sample and do serendipitous discoveries, but it's also a great outreach tool, which was used for teaching, for example. And so you can give it a try and give us your ideas on this platform. Thank you.
Thanks, Hugo, for your talk. Question?
Mara Salvato. Thanks, fantastic. I was wondering whether it would be possible to ingest other sample of sources. So suppose that Rosita people have a bunch of sources that would like to have the citizens to classify. How easy will it be to create a space where a sample of these objects is ingested there?
I would say as soon as you have a HIPS map of Rosita and a catalog with basic information like the coordinates and the training sample, that would be quite easy. Yeah. Yeah. Okay.
Do you have Stephen Chen? Do you have I guess, a publication in the works for some of these classified sources?
Not yet. Well, so far I'm working on the Klaxon on my free time, so I don't have any publication yet, but that's definitely something I want to have.
Thank you.
So the spectra and the light curves that you have shown to the user, they're just static images, right?
Yeah, absolutely.
Have you thought about maybe doing some JavaScript so the user can refin them and maybe look at them in a slightly different way?
Yeah, actually, that's part of the features I think we proposed in the survey, but that's too much too difficult for me to develop, I think. But yeah, that would be very interesting.
Please.
Well, thank you very much, Hugo. I've been using Klaxon a lot, but I was wondering, how would you deal with the fact that, anyone could blindly say this source is an IgA and still get something like 90% of accuracy, since this is very unbalanced sample.
So we do so the training sample is not as unbalanced as this. So it's not a 90% of AGN, but it's maybe 60%. Still, it's a majority of AGN, and so I've started to work on better metrics to assess the success rate of users, as we already have in a confusion matrix, for example. So, like, if we could imagine maybe the F1 score or the generalized F1 score of the class of the volunteer, and base this success rate on this metric. Yeah, I think.
Hi. So you saw that you have, sorry, I'm Angel Ruiz. You have like 140 users, right?
Well, that was last year, yes.
Okay. Now, the thing is, and I see that you have at least 5 very engaged users. And my question is, I mean, from the total people that start using the system, how many come back and keeps going and trying? Because I see, for example, in your plot about the ages of users, you have few children like 11 years old, something like that.
Yeah.
That I guess that is that someone goes to their school, show them the tool, they try it. How many of those come back and actually engage with this?
Yeah, so most people just stay for 1 day, but this is because we don't have a notification system yet, and some people very involved stay for a few weeks or months, and these two have classified the whole sample available on Klaxon. So if they keep going on Klaxon, they are saying, "Oh, sorry, we don't have more sources for you."
You finish the game.
Yeah, that's it.
Jean Vallée, at some point you said that you trusted more the results from Klaxon than Klaxboy. I was wondering, on what basis did you actually use extra information that is not available to either? Or is it simply because the images and the light curves and the time series that are plotted are richer than the parameters that are used in Klaxboy?
Yeah, it's not the second thing, because Klaxboy doesn't use, for example, the shape of the spectrum or the shape of the light curve. And we do see that. So when I inspect the source, I do see that and use that in my own expert classification. So yeah, and the way I did that was by basically providing my own classification without looking at all at the Klaxon answer, and then comparing and the Klaxboy either, of course, and then comparing my answer to the one of Klaxon and Klaxboy, and so that's how I said that most cases the Klaxon-based classification is more trustable, but it's 25 objects, so not yet enough to make some strong conclusions.
We have time for more questions. Thanks again, Hugo, for your talk.